malignant tumor cells. Right? It is something related to malignant tumor cells. Now, what exactly is happening in this metastasis? How are the cells able to detach themselves? How the cells are able to detach themselves? Right. So if we see, actually speaking, in our body, we have all the cells which are actually present like this. Right. So these cells are all said to be connected to each other. Right. So they are said to be connected to each other with the help of a protein substances. Right. So all these are the protein substances. So these proteins are usually referred to as cell adhesion proteins. So we would have already studied this in our first year. We call them as cell adhesion proteins, right? Or we can also call them as intercellular adhesion proteins, right? So one of the major intercellular adhesion protein is called cadherins. Right? We have something called as cadherins. So these cadherin proteins are the ones which actually hold the two cells together so that the cells are held together in their place, such that tissue is being formed. So two cells are held together with the help of this intercellular adhesion proteins called as cadherins. Right. Now, what happens? So this is in normal condition. When the cancer cells start undergoing the process of division, right, as and when the cancer cells would start increasing in number, they would start sharing the cadherin molecules. All of these cells would start sharing the cadherin molecules. As and when the number of cells drastically increase, the concentration of cadherin will start decreasing. Right? Let me repeat it once again. All the cells are held together with the help of these intercellular adhesion proteins, which are called as cadherins. As and when the concentration, as and when the number of cells start increasing, the amount of cadherins will start decreasing. So as and when the amount of cadherin starts decreasing, slowly these two cells, which are held very tight, will start loosening up. As and when they start loosening up, some of these cells will now start detaching from here and they enter into the bloodstream, and through the bloodstream they would enter into distant organs where they would develop into a secondary tumor. Right? So that is what is happening here through the process of metastasis. So when we talk about metastasis, what exactly is happening in metastasis is the cadherins, the concentration of cadherins would be drastically decreased, because of which the cells will be no longer able to held close together. The cells will lose their contact, as a result of which some of the cells would start detaching because of low cadherin concentration, and they would start moving or migrating to distant places where they would get lodged in different organs and they would start developing into secondary tumors. Right? So this is what is happening. So this is the second characteristic feature of the cancer cells, which is called as metastasis. First one, uncontrolled growth, right? Uncontrolled division. Second one is metastasis, right? Next, the third characteristic feature of the cancer cells, right? So the third characteristic feature of the cancer cells is something called as angiogenesis. It is called as angiogenesis. Now, what do we mean by this term angiogenesis? What does angiogenesis mean? Angio is something to do with blood vessels, right? Angio refers to blood vessels. So wherever you find the term angio, automatically you can link it with something called as blood vessels. Genesis, we know what does the term genesis mean? Genesis means formation, right? So angiogenesis is nothing but formation of blood vessels. Now, again, remember, let's get back to this. As and when the concentration of this cancer cell starts increasing, as and when the number of cancer cells starts increasing, they would start requiring more nutrients as well as oxygen for their growth and survival. So what do? They would start extracting the blood vessels from the normal cells. Right? So they would start extracting the blood vessels from the normal cells. Why they should extract the blood vessels from the normal cells? Only if they have their own blood vessels, right? Again, I'm repeating, only when the cancer cells have their own blood vessels, right? Only when they have their own blood vessels, they would have enough of nutrients as well as enough of oxygen for their growth and survival. So they would start extracting blood vessels from the normal cells, such that whatever nutrients comes to this normal cell, those nutrients and oxygen would be now diverted to the cancer cells. Right. So this process of formation or generation of the blood vessels from the normal cells is called as angiogenesis. Another characteristic feature of the cancer cells, angiogenesis. So what exactly are they doing? These cancer cells, as and when they start increasing in number, right? As and when they would start increasing in number, they would start extracting the blood vessels from the normal cells. As a result of which, they would get enough of nutrients and oxygen for their survival. So during this process, what is happening? As and when the nutrients and oxygen go to the normal cells, those nutrients and oxygen from the normal cells would be diverted to the cancer cells, such that these cancer cells are now having enough of nutrients and oxygen, while the normal cells are being starved of nutrients as well as oxygen. So as a result of which, what is happening? Cancer cells are surviving, they are multiplying and they are growing, whereas the normal cells will start dying due to lack of nutrients as well as oxygen. Right. So that process of extraction of blood vessels from the normal cells, we start calling it as angiogenesis. Right. So this angiogenesis pathway plays a very, very important role in the treatment processes. Right. So nowadays, the scientists and doctors, they are actually targeting on this process of angiogenesis. Right. So if we are successful in inhibiting the process of angiogenesis, if we are successful in inhibiting the process of formation of these blood vessels or extracting the blood vessels, we can kill the cancer cells. Thereby, we can protect the normal cells and kill the cancer cells. So there are several drugs which are being designed nowadays, right, to inhibit the process of angiogenesis, to inhibit the process of blood vessel formation by the normal cell. As a result of which, we can start destroying the cancer cells. Right? So this is another important property here, which is angiogenesis. The next property of cancer cells is something called as apoptosis. Right? It is called apoptosis. Now, what is this apoptosis all about? Apoptosis is nothing but, it is usually referred to as programmed cell death. It is usually referred to as programmed cell death. Now, what does this mean? Programmed cell death. The death of the cell is already programmed. That's what it means, right? Programmed cell death. As and when a new cell is actually formed, right? So this is the normal process that occurs in our body, right? All the cells in our body have a limited lifespan, right? So as and when a new cell in the body is formed, that cell is always programmed to die on so and so date after its lifespan is over. Let's take the example of well-known example, RBC. So we all know that the lifespan of RBC is 120 days. As and when a new RBC is formed, this particular new RBC here, is programmed to live only for 120 days. Right? It is programmed in such a way that after 120 days, it would start undergoing autolysis. Right? It would start undergoing autolysis. That is nothing but self-destruction. It would start undergoing self-destruction. So for that, we have cellular organelle called lysosome that is being present. Right. So we have studied, right? Lysosome is called as what? The suicidal bag of the cell. Why do we call the suicidal bag of the cell? Because it aids in a mechanism called as suicide, self-death, autolysis. So after 120 days, the lysosomes present in this particular cell will become activated. Once the lysosomes become activated, they will start releasing their hydrolytic enzymes such that this entire RBC would get autolyzed. It would undergo the process of lysis. That process we start calling as programmed cell death. So not only RBCs, each and every cell present in our body is being programmed in such a way that at the end of its lifespan, it would start undergoing the process of autolysis. So that mechanism we start calling it as apoptosis, which is also called as programmed cell death. Right. Now, why we are talking about this is one of the characteristic feature of this cancer cells is lack of apoptosis. Right. So they do not have this particular process of apoptosis. They usually lack this process called as apoptosis. since they lack this process called as apoptosis, what would happen? Right? Since they lack this process of apoptosis, what would actually happen? What would happen? They would not die. Right? Even after their lifespan is over, also they will not die. They would keep on multiplying. Right? So there is lack of apoptosis seen in this particular cancer cell. Whereas all the normal cells, they usually undergo this particular process called as apoptosis. Right? So four important characters we have seen of cancer cells: controlled, uncontrolled growth. Second one, metastasis. Third one, they undergo the process of angiogenesis. And fourth, they do not undergo the process of apoptosis. Right? Last property or last character of the cancer cell is, the last one is, they have certain specific antigens, surface antigens. Right. So the scientists say that all of these cancer cells, they have an unusual surface profile or unusual antigen profile. Right. So what happens is, say if this is the cancer cell, on the surface of cancer cell, there are certain specific receptors which are present, which are said to be unusual receptors that are present. Right. Not the normal receptors which is present in case of human cells, but different receptors than that of the human cells. Right. So we start calling them as surface antigen. So they have an unusual surface antigen which can be easily identified by either the NK cells as well as the TC cells. Right. So we know what are these NK cells and TC cells. Right. Natural killer cells as well as cytotoxic T lymphocytes. So this NK cells and the TC cells, they have the ability of identifying the surface antigen, as a result of which they are able to destroy this particular cancer cells. Actually speaking, one way the cancer cells are helping us, are helping our immune system to recognize them and to fight against them. Right? So they have unusual surface antigens present on their membrane, through which our natural killer cells as well as the TC cells, they are able to identify those particular cells and they are able to bring about the destruction of those particular cells. Right. So these are certain characters of unique characters which are actually present in the cancer cells. So five major unique characters which are a part of the cancer cells. So what are those unique characters? First one is uncontrolled division or uncontrolled growth. Second one is they undergo the process of apoptosis. Then they would undergo the process of angiogenesis. Then there is apoptosis, lack of apoptosis, and they have unusual surface antigens present on that surface, through which our own immune cells, they are able to recognize those particular foreign cancerous cells, and they are able to fight against those cancer cells. Right. So this is what we have, the characters of cancer. Right. So in the next session, let us take up with the causes of cancer. What actually causes cancer? And we'll see how exactly the cancer cells undergo the process of proliferation. What is the progression of cancer? So once we are done with that, then we'll move on into the detection part of cancer. Fine. Thank you.
Good afternoon to everyone. Today also we are going to discuss differential equations. So that is variable separables. Already know the concept of variables and separables. Variables, separable. Variable separable means if the differential equation, for example, x y or x dy by dx is equal to y. X dy by dx equal to y by x. Now we have to separate that x dx terms and y dy terms. X dx terms and y dy terms. So it is dy divided by y. Dy divided by y is equal to 1 by x into dx. By cross multiplication it is dx 1 divided by x. Now it is y dy terms and x dx terms. So now apply integration on both sides. Integral of 1 by y dy is equal to integral of 1 by x dx. So integral of 1 by x is equal to log mod x. Integral of 1 by y dy is equal to log y. Integral of 1 by x log x plus c also constant c. It is indefinite integrals, so must we have to write constant c. So the total equation in terms of log, so plus log c. So here RHS is log a plus log b form. Log a plus log b is equal to log of a. Log y is equal to log of cx. Y is equal to cx. It is the required solution of the differential equation. So here given x dy by dx equal to y. 1 by y dy is equal to 1 by x dy. So here y dy terms and x dx terms. Separate that x dx term and y dy term. It is this process of finding integrals of your function is called variable separable. For example, definition. If the differential equation is of the form dy by dx is equal to f of x by g of y. If the differential equation is of the form dy by dx is equal to f of x by g of y, then or separate that by cross multiplication g of y dy is equal to f of x dx. So f g of y dy is equal to f of x dx. Then apply integration. Integral of g of y dy is equal to integral of f of x dx plus c. So this process of finding integrals of a functions are called variables separables. Okay, na? So it is write down. So heading variables separable. Variables separable. Write down. If the differential equation is of the form dy by dx is equal to f of x by g of y, f of x by g of y, or g of y dy is equal to f of x dx. G of y dy is equal to f of x dx. G of y dy is equal to f of x dx. Then it is said to be variables separable. It is said to be variables separable. And such equations Such equations can be solved by integrals on both sides. Can be solved by integration on both sides. Integration on both sides. The solution is given by. The solution is given by. The solution is given by integral of g of y dy is equal to integral of f of x dx plus c, where c is a constant. C is a constant. Okay, na? Write down exercise 9.4. Simply identify variable separable means separate that y dy terms and x dx terms. Then apply integration on both sides. This process is called variable separables. Write down exercise 9.4. dy by dx is equal to dy by dx is equal to 1 minus cos x divided by 1 plus cos x. Exercise 9.4. For each of the following equations, find the general solution. So here dy by dx is equal to 1 minus cos x by 1 plus cos x. You know that 1 minus cos x, it is a 2 sin square x by 2. Multiple submultiple trigonometric formulas. 1 minus cos x is equal to 2 sin square x by 1 plus cos x, 2 cos square x by 2. 2 to remove. dy by dx is equal to sin square by cos square tan square x by 2. By cross multiplication, dy is equal to tan square x by 2 dx. Now it is LHS is a dy, RHS is a dx. Then apply integrals on both sides. Integral of dy is equal to integral of tan square x by 2 dx. Already separate that y terms and dx terms. Then apply integration. Integral of dy, that means 1 dy. Integral of 1 dy means y. Integral of tan square means trigonometric identities. Secant square theta minus tan square theta is equal to 1. Tan square is equal to secant square minus 1. There is no integral of tan square. So it is converted to secant square minus 1. So integral of secant square, that is tan, divided by derivative of x by 2, 1 by minus integral of 1 is x plus c. So clearly y is equal to 2 tan x by 2 minus x plus c. It is the required solution of the differential equation. Listen once again, dy by dx equal to 1 minus cos by 1 plus cos. By applying trigonometric formulas, 1 minus cos x equal to 2 sin square x by 2, 1 plus cos equal to 2 cos square x. Sin square by cos square is tan square. Tan is equal, tan square x by 2 is equal to secant square x by 2 minus 1. Apply integration. Integral of 1 dy is y. Integral of secant square equal to tan. Secant square x by 2. Tan square x by 2 divided by derivative of x by 2. That is 1. Integral of 1 is x. So 2 tan x by 2 minus x plus c. Can I write down? Yeah, everybody. Okay, ma. Write down second question. Second one. dy by dx is equal to root of 4 minus y square, but it is a minus 2 less than y less than 2. Solve the differential equation. Dy by dx is equal to root of 4 minus y square. Dy by dx is equal to root of 4 minus y square. Dy by root of 4 minus y square is equal to dx. So here LHS dy by root of 4 minus y square. RHS is dx. Already it is separated x terms and y terms. So LHS y terms, RHS only dx. Then apply integration. Integral of 1 divided by root of 2 square minus y square dy is equal to integral of 1. It is 1 by root of a square minus x square form. What is the formula? Integral 1 by root of a square minus x square? Sin inverse of x by a. So integral of 1 by root of 2 square minus y square du. It is sin inverse of y by 2. Formula sin integral of 1 by root of a square minus x square. Sin inverse of x by a. Here in terms of y, so sin inverse of y by 2 is equal. Integral of 1 is x plus c. What about y by 2? It is sin of x plus c. Y is equal to 2 sin of x plus c. It is the required solution of a differential equation. Required solution. Y is equal to 2 sin of x plus c. Okay, write down. Again, write the next question. Form the general solution of secant square x tan y dx plus secant square y tan x dy is equal to 0. Form the general solution equation, or find the general solution of secant square x tan y dx plus secant square y tan x dy is equal to 0. Okay? It is secant square x dx, but here I am having a y. Secant square y dy, it is a tan x. It is a, in this term we have to remove that tan x. In this term we have to remove tan y. Secant square y tan x dy is equal to secant square x tan y dx. Now we have to remove. It is converted to. It is converted. So here secant square of y divided by tan y dy is equal to secant square x divided by tan x dx. Now here LHS terms total are in terms of y. In RHS each and every term in terms of x. Already it is separated. Okay na? LHS y dividers, RHS x dx term. Now apply integration. Integral of secant square y by tan y dy is equal to integral of secant square x divided by tan x dx. It is f of x. Derivative of tan is secant square. So it is f dash of x by f of x form. Integral of f dash of x by f of x. What is the formula? Log mod f of x. It is a log of tan y. Derivative of tan is secant square. Integral of f dash of x by f of x is equal to log of tan x plus log c. Constant also consider. Generally it is constant c. C1, 2, C3, C5 all are constant. Okay na, here it is log of tan y, it is log of tan x. So constant also consider log. In RHS it is log a plus log b form. Log a plus log b, log of b. So log of tan y is equal to in RHS log c into tan x. Log a plus log b form. Log ab. So log of, sorry, it is minus na. It is total term converted to RHS we get a negative. Okay na? Log a minus log b, log of a by b, c divided by tan x. So both sides remove that log, then we get tan y is equal to c divided by tan x. Then by cross multiplication, tan x tan y is equal to c. It is a required general solution of the differential equation. So here given secant square x tan y dx, secant square y tan x dx. So it is converted to RHS, we get a negative. It is secant square x dx, tan y removed. That means it is converted to LHS by cross multiplication. In LHS, secant square y dy, here having tan x. This is tan x converted to RHS. That is divided by. It is minus. Okay, then apply integration. F dash of x by f of x. Integral of f dash of x by f of x, log mod f of x. Okay, log of tan x tan y is equal to log of c divided by tan x. Why? Because it is log a minus log b from log of a by b. Both sides remove that log. Tan y is equal to c by tan x. Tan x and tan y is equal to c. Right down. Okay, ma'am. Write the next question. Write down. E power x plus e power minus x dy minus e power x minus e power minus x whole dx is equal to 0. So it is e power x plus e power minus x dy minus e power x minus e power minus x whole dx is equal to 0. First e power x plus e power minus x dy converted to RHS. Minus it changes to plus. E power x minus e power minus x dy is equal to e power x minus e power minus x divided by e power x plus e power minus x whole dx. So LHS only dy, RHS term having it is x dx. Then apply integration. Integral of 1 dy is equal to integral of e power x minus e power minus x divided by e power x plus e power minus x whole dx. Derivative of e power x is e power x. Derivative of e power minus x, that is a minus e power minus x. Clearly it is f dash of x divided by f of x. What is the formula? Integral of f dash of x by f of x? Log f of x. So integral of 1 dy means it is y is equal to log of e power x plus e power minus x plus c. That's 61. dy by dx is equal to 1 plus x square into 1 plus y square. Find the general solution of dy by dx is equal to 1 plus x square into 1 plus y square. So find the general solution of dy by dx is equal to 1 plus x square into 1 plus y square. dy by dx 1 plus x square 1 plus y square. So it is divided by 1 plus y square. dy by 1 plus y square. dy by 1 plus y square. Here 1 plus x square into dx. 1 plus x square into dx. Then apply integration. Now here LHS total terms in terms of y, RHS terms in terms of x. Then apply integration. Integral of 1 by 1 plus y square dy is equal to integral of 1 plus x square dx. Integral 1 by 1 plus x square formula tan inverse of x. Integral of 1 by 1 plus y square dy, it is a tan inverse of y is equal to integral of 1 is x plus integral of x square is x cubed by 3 plus 6 or y is equal to tan of x plus x cubed by 3 plus both correct. Okay na? Here only tan inverse of y is equal to x plus x cubed by 3 plus 6. Okay na? So it is here given the functions are mixed functions. First to separate that x dx terms and y dy terms, then apply integration on both sides. The process of finding integrals of a function is called variable sum. We can write down. Write down. Those are completed. Try to solve next question. Okay, now next. Y log y dx minus x dy is equal to 0. Solve the differential equation and find the general solution of the equation y log y dx minus x dy is equal to 0. X dy is equal to y log y dx. This convert to RHS, that is y dy. Y dy is equal to, sorry, x dy is equal to y log y dx. Here it is x dy. So this x we have to convert to RHS. This y log y converted to LHS. So dy divided by y log y is equal to dx divided by x. It is 1 by y log y. It is also 1 by y divided by log y is equal to 1 by x dx. Same 1 by y divided by log y. It is 1 by y log y. Then apply integration. Integral of 1 by y log y is equal to integral of 1 by x dx. Integral of 1 by x log. It is f dash of x by f of x. Denominator is log y. Derivative of log y with respect to y. 1 by y. It is f dash of x by f of x. So it is a log of log y. Log y is equal to log x. Integral of 1 by x is log x. F dash of x by f of x from log f of x plus constant c. In RHS, log A plus log B form. Log A plus log B is equal to log of AB. Both sides remove that log. Then we get a log Y is equal to CX. It is a logarithmic form. Log Y. Log means base is here. This logarithmic form converted to exponential form. That means Y is equal to e power Cx. It is a logarithmic form, it is exponential form. Log Y. Log means base is the standard. So Y is equal to e power Cx. It is the required solution of the general solution. Okay, ma, write down next question. X power 5 dy by dx is equal to minus y power 5. X power 5 dy by dx is equal to minus y power 5. So it is dy by dx is equal to minus y power 5 divided by x power 5. Cross multiplication. Dy by y power 5 is equal to dx by x power 5. Okay, dy by y power 5 dx divided by x power 5. So it is y power minus 5 dy is equal to minus x power minus 5 dx. Then apply integration on both sides. Integral of y power minus 5 dy is equal to minus integral of x power minus 5 dx. Then apply integral of x power n formula. Integral x power n is equal to x power n plus 1 by n plus 1. So it is y power minus 5 plus 1 divided by minus 5 plus 1 is equal to minus x power minus 4 by minus 4 plus c. It is y power minus 4 is equal to minus x power minus 4 minus c. C or C1. So it is c is a constant, C1 is a constant. Minus 4 C1 also constant. So it is x power 4 plus y power minus 4 is equal to c, where c is equal to minus 4 C1. C1 constant, C constant, 2C, 3C, 4C all are constants. Okay, na? So instead of minus 4 C1 is C. So x power minus 4 plus y power minus 4 is equal to c. Right down. Okay, write down next question. Write down next one. E power x tan y dx plus 1 minus e power x secant square y dy is equal to 0. Again, it is 1 minus e power x secant square y dy is equal to minus e power x tan y dx. 1 minus e power x secant square y dy. It is converted to RHS, so we get to negative. Minus e power x tan y dy. So here 1 minus e power x, it is converted to RHS. Why? Because it is dy. So x term converted to RHS. It is dx. This tan y converted to RHS. So secant square y divided by tan y is equal to e power x divided by 1 minus e power x dx. Then apply integration. Integral of secant square y divided by tan y dy is equal to integral of minus e power x divided by 1 minus e power x dx. Now it is f dash of x by f of x from LHS. Derivative of tan secant square. Derivative of 1 minus e power x minus e power x. So LHS RHS both integral of f dash of x by f of x. So log of tan y is equal to log of 1 minus e power x. F dash of x by f of x. It is also f dash of x by f of x. So log plus log c. log of tan y is equal to log of c into 1 minus e power x. RHS log A plus log B form. So tan y is equal to c into 1 minus e power x, or y is equal to tan inverse of c into 1 minus e power x. No need. Up to here only tan y is equal to c into 1 minus e. Okay, na? Copy this one. Today class is completed. Tomorrow we'll go to discuss continuation on this exercise. Okay. Take care.